Imagine yourself scrolling through videos. They show distant lands. They show bustling cities. Now picture a video of a sunset, but this is not a sunset on Earth. This is a sunset on Proxima Centauri b, a planet orbiting the nearest star to our Sun. Proxima Centauri b is a real place. It is a planet just a little bigger than our own. It orbits its star within the habitable zone. This means it could have liquid water, a key ingredient for life. This is not science fiction. This is a potential future for humanity. It is a future where we cross the immense gulf of interstellar space to explore new worlds. It is a journey that will test our technology, our courage, and our very understanding of our place in the cosmos. But first we must dream. We must imagine the impossible. We must believe that reaching for the stars is not just a fantasy, but a destiny we can choose to embrace. The biggest challenge facing interstellar travel is, of course, distance. The vastness of space is almost incomprehensible, stretching out in all directions with seemingly no end in sight. Proxima Centauri, the closest star to our solar system, is 4.24 light-years away. To put that into perspective, 1 light-year is about 5.88 trillion miles. That means light itself, traveling at 186,000 miles per second, takes more than 4 years to get there. This speed is the ultimate speed limit in the universe, yet even it seems slow when faced with interstellar distances. Our fastest spacecraft today, like the Voyager probes, would take tens of thousands of years to make that journey. These probes, traveling at about 38,000 miles per hour, are a testament to human ingenuity, but they highlight the immense challenge we face. Clearly, we need a different approach. Traditional methods won't suffice for such monumental distances. We need technologies that can propel us through the vast emptiness of space at a significant fraction of the speed of light. This is not easy. It requires breakthroughs in propulsion systems, energy sources, and material science. It requires us to rethink our fundamental assumptions about space travel. We must innovate and push the boundaries of what we believe is possible. We must move beyond the limitations of chemical rockets, which have served us well for decades but are not suitable for interstellar travel. We need to harness new forms of energy and propulsion if we hope to bridge the immense gap between the stars. Concepts like nuclear propulsion, solar sails, and even antimatter engines are being explored. But the rewards are worth the effort. The universe is filled with wonders, from breathtaking galaxies to stunning nebulae, each holding secrets waiting to be discovered. The universe is filled with wonders. Every star, every planet, every celestial object holds the potential for new knowledge and new discoveries. Reaching for them can inspire us. It can unite us. The quest for interstellar travel is not just a scientific endeavor, it's a human one, bringing together people from all walks of life and from all corners of the globe. It can push the boundaries of human ingenuity and imagination. The challenges we face in interstellar travel can lead to technological advancements that benefit all of humanity. The journey to Proxima Centauri is a journey to the very edge of the possible. It represents the pinnacle of human ambition and the relentless pursuit of knowledge. It is a journey we must dare to take. The stars beckon us, and with determination, innovation, and unity, we can answer that call and explore the vast cosmos that lies beyond our solar system. For generations, chemical rockets have been the workhorse of space exploration. They are powerful, they are reliable, but they are not efficient enough for interstellar travel. Think of a car. A chemical rocket is like a car that uses all its fuel in the first few seconds of acceleration. To reach another star, we need a spacecraft that can accelerate continuously. It needs to reach a significant fraction of the speed of light. This requires new technologies. Scientists are exploring various options, some are more theoretical than others, but they all share the same goal: to break free from the constraints of chemical propulsion. We need to unlock the potential for true interstellar flight. The future of space travel lies in harnessing the fundamental forces of the universe. This includes gravity, electromagnetism, and even the power of the sun itself. These are the keys to unlocking the vast distances of interstellar space and opening up a new era of exploration. Section 4. Ion propulsion, riding the gentle force of electric winds. One promising technology that is revolutionizing space travel is ion propulsion. This technology is not just a concept of the future, it is already being used in various missions, showcasing its potential and efficiency. Ion drives work by using electricity to accelerate ions, creating thrust. This process involves ionizing a propellant, usually xenon, and then using electric fields to accelerate these ions to high speeds, generating a gentle but continuous thrust. It's a gentle force, much like a gentle breeze pushing a sailboat across the ocean. This analogy helps us understand how ion propulsion, despite its low thrust, can be incredibly effective over long durations. While ion thrusters provide very low thrust compared to traditional chemical rockets, they are incredibly efficient. This efficiency means that they use far less propellant, making them ideal for long-duration missions where carrying large amounts of fuel is impractical. They can operate for years, allowing them to achieve very high speeds over time. This continuous operation is what sets ion propulsion apart, enabling spacecraft to gradually build up speed and cover vast distances. Imagine a spacecraft that can continuously accelerate for years on end. This continuous acceleration, though slow at first, accumulates over time, allowing the spacecraft to reach speeds that would be impossible with traditional propulsion methods. It would eventually reach a significant percentage of the speed of light, making interstellar travel a real possibility. This opens up new horizons for exploration, potentially allowing us to reach distant stars and planets. Several spacecraft have already used ion propulsion successfully. These missions have provided valuable data and proven the viability of this technology in real-world applications. NASA's Dawn spacecraft used an ion thruster to visit the asteroid Vesta, showcasing the ability of ion propulsion to navigate and maneuver in space with precision, and then journeyed on to the dwarf planet Ceres. This mission demonstrated the capability of ion propulsion to undertake complex, multi-destination missions. These missions demonstrated the reliability and efficiency of this technology, proving its potential for long-duration spaceflight. The success of Dawn has paved the way for future missions that will rely on ion propulsion, proving its potential for long-duration spaceflight. The ability to operate continuously for years without the need for large amounts of fuel makes ion propulsion a game-changer for space exploration. Ion propulsion may be a key technology for reaching Proxima Centauri, our nearest star system. The efficiency and longevity of ion thrusters make them ideal for such ambitious missions. It represents a shift in thinking about space travel, prioritizing efficiency and long-term sustainability over brute force. This new approach could redefine our capabilities in space, making the dream of interstellar travel a reality. Section 5: Solar Sails Harnessing the Sun's Energy for Interstellar Flight. Another intriguing possibility for interstellar travel is the solar sail. Imagine a giant reflective sail much like the sail of a ship, but instead of wind, it is pushed by sunlight. Photons, the particles that make up light, have momentum and can exert a force. A large enough sail could use this force to propel a spacecraft, like a cosmic sailboat riding on a beam of sunlight. Solar sails have the advantage of requiring no onboard fuel. They would be limited in their initial acceleration, but they could theoretically reach very high speeds over time. This makes them potentially well-suited for interstellar voyages. While still in the early stages of development, solar sails hold great promise. They represent a truly elegant and sustainable way to explore the cosmos, embodying the spirit of harnessing the universe's own energy to power our ambitions. Section 6: The Body in Space, the Human Challenge of Long-Duration Missions. Traveling to another star system is not just about building a faster spacecraft, it is about ensuring the well-being of the crew. The human body did not evolve for space travel, and long-duration spaceflight poses significant challenges to human health. One major concern is the effect of microgravity on the body. In space, bones lose density, muscles atrophy, and the cardiovascular system is also affected. These changes can have serious long-term consequences for astronauts. Another challenge is radiation exposure. Space is full of harmful radiation which can damage DNA, increase the risk of cancer, and cause other health problems. Protecting astronauts from radiation is crucial for ensuring their safety and well-being on a multi-year journey to another star. Addressing these challenges requires a multi-pronged approach, involving the development of advanced life support systems, the creation of artificial gravity environments, and finding effective ways to shield astronauts from radiation. Section 7: The Mind in Space, Psychological Resilience for Interstellar Voyagers. The physical challenges of interstellar travel are significant, but the psychological challenges are just as daunting. The human body can be conditioned to withstand the rigors of space, but the mind requires a different kind of preparation. Imagine being confined to a spacecraft for years with the same small group of people, millions of miles from Earth. The vast emptiness of space outside and the limited space inside can create a unique set of psychological stressors. The isolation, confinement, and lack of familiar sensory input could take a toll on even the most well-adjusted individuals. The absence of natural light, fresh air, and the sounds of nature can lead to sensory deprivation, which can affect mental health. Astronauts on a multi-year mission to Proxima Centauri would need to be carefully selected for their psychological resilience. Rigorous psychological evaluations and resilience training would be essential to ensure they can handle the prolonged stress and isolation. They would need extensive training and support throughout the mission. Regular psychological check-ins, virtual counseling sessions, and peer support groups would be vital in maintaining mental health. Creating a sense of purpose and community on board the spacecraft would be crucial. Team-building activities, collaborative projects, and shared goals can foster a sense of camaraderie and belonging. Astronauts would need to feel like they are part of something larger than themselves, contributing to a historic endeavor. Celebrating milestones and achievements can boost morale and reinforce the mission's significance. Virtual reality, communication with Earth, and opportunities for creative expression could all play a role in maintaining mental well-being. Virtual reality can simulate familiar environments, while regular communication with loved ones can provide emotional support. The success of an interstellar mission depends not only on technological prowess, but also on the human spirit's strength and resilience. The ability to adapt, stay motivated, and support one another will be key to overcoming the psychological challenges of deep space travel.